Welcome to this explainer. Today, we're turning back the clock and looking at the absolute foundational principles of reading historical manuscripts. If you've ever actually looked at an original medieval document, you know firsthand it's not exactly like reading a modern paperback. In fact, it often feels like you've been dropped right into the middle of a thrilling, cryptographic detective story. Every little scratch of the quill, every loop, every dot, they might hold the key to uncovering lost history, scientific discoveries, or ancient medical practices. So, the million-dollar question we're exploring today is this. How exactly do you read a text that looks like a literal secret code? Because, let's be honest, to the untrained eye, medieval manuscripts are pretty much impenetrable. They don't just use different languages, they use entirely different visual systems for writing. Reading them requires specialized tools, a deep understanding of historical context, and, well, more than a little patience.
Section 1. The problem. Historical zip files.
Okay, let's dive into this. The biggest hurdle in reading historical manuscripts isn't necessarily the handwriting itself. It's what that handwriting represents. You see, scribes used a massive, incredibly complex system of abbreviations to save precious, very expensive parchment and time. They acted, quite literally, like a historical zip file. Just as an example, a busy 14th century scribe wouldn't write out the full Latin word absolution. No way. Instead, they'd compress it down to abs or Absalom with just a simple little stroke over it to indicate missing letters. Now, multiply that practice across thousands of words, throw in regional variations and different academic disciplines, and you can quickly see why reading these old texts is so incredibly daunting. You really do have a secret code where you have to unpack every single compressed word. Fortunately for us, historians have an ultimate decoder ring for this exact problem. Enter Capelli Online. Originally compiled as a giant physical dictionary by Adriano Capelli, the Ad Fontes project at the University of Zurich went ahead and digitized this massive resource. It's now a fully searchable, digital database containing over 14,000 medieval Latin abbreviations. This tool single-handedly transforms the analog nightmare of deciphering compressed scribbles into a totally manageable digital process. What makes Capelli Online so unbelievably powerful is its searchability. If you're staring at a strange symbol in a manuscript, you don't just have to guess anymore. The database lets researchers filter through all 14,000 plus abbreviations using highly specific criteria. You can filter by the category of the text, is it medical, is it juridical? You can filter by language, whether it's Latin, Italian, or German. You can even narrow it down by the specific geographic location the document came from, or the exact script type, like Carolingian or Gothic. This incredible precision helps researchers pinpoint the exact meaning they need to unpack the text.
Section 2. The ultimate cold case. The Voynich manuscript.
And this brilliantly illustrates our next point. For over a century, the infamous Voynich manuscript, also known as MS408, has defied every single attempt at translation, completely frustrating cryptographers and historians alike. It's the ultimate cold case. But a newly proposed approach shows us how to tackle it using the exact principles we just talked about. A researcher named René Lüth published an analysis suggesting that the Voynich script isn't an alien language or pure gibberish, but rather a highly structured geometric cipher. The theory argues that the characters were deliberately designed as an optical illusion. At first glance, they mimic the medieval Latin shorthand we just learned about, but beneath that, they're actually encoded using a historical cipher system created around 1430 by Giovanni Fontana. So, how does this proposed decoding method actually work? Well, first, you have to visually break down the Voynich text. Instead of seeing letters, you break each symbol down into its underlying geometric components, specifically open and closed circles with various stems and strokes. Then, for the second step, you map those geometric features directly against the historical 1430 Fontana speculum wheel. This wheel acts as the cipher, translating those geometric shapes back into standard alphabet letters. But here is where the core foundation of reading historical texts comes roaring back into play. The letters you get from the cipher, they don't spell out full words. Instead, they spell out highly reduced abbreviations, often just one or two letters. This brings us to the absolutely crucial third step, taking those deciphered letters and running them straight through the Capelli Online database. For example, a symbol yielding the letter C maps to croci, which is the medieval Latin term for saffron. B translates to badiani, or star anise. O translates to oleo, meaning oil. So the text isn't a flowing narrative, it's a heavily abbreviated list of ingredients. When you run an entire page through this process, like folio 1R of the manuscript, you get raw Latin text that looks something like this. Fiat aqua natrum decoctio gumi, Croci, Crocibadiani, Oleo Aromonicus. Notice there is zero narrative grammar here. There are almost no verbs. It reads purely as a technical laboratory protocol, a stripped-down, highly efficient list of chemical instructions. It is the ultimate medieval zip file in action. When you expand those abbreviations into their full context, the cryptography suddenly brings history right to life. Folio 1R reveals itself to be a highly specific alchemical recipe. The instructions tell the reader to purify water with natron and gum, mix it intensely with a double dose of saffron and star anise, add aromatic oil, and fold the mixture repeatedly until homogeneous. Researchers believe this reconstructs the actual instructions for a saffron-based medicinal oil or ointment, very likely intended for treating infections in 15th century soldiers. How cool is that? Now, the real test of any decoding theory, for sure, is whether it works consistently. Applying the exact same methodology to the next page, Folio 1V, yields a completely different yet equally coherent list of Latin terms. The raw output here gives us words like calx, salus nitri, and sulphurous. We are definitely no longer dealing with saffron and aromatic oils. This page is talking about lime, saltpeter, and sulfur, combined with vitriol oil and undergoing repeated heating and cooling processes. These specific chemical components are highly revealing. Lime, saltpeter, and sulfur processed together are classic, textbook components of medieval chemistry. This mixture strongly points to the production of early gunpowder components, incredibly caustic wound treatments, or a base for alchemical transformations. The fact that this information is so heavily encrypted and abbreviated further suggests that the Voynich manuscript was the highly secret working notebook of a medieval military physician or practicing alchemist. Let's move to Folio 2 and see how this builds across the rest of the manuscript. As researchers applied this geometric and Capelli-based method to subsequent folios, the results remained remarkably consistent and historically accurate. Folio 2R outlines extracting tinctures from roots and herbs. Folio 2V describes distilling almond oil, roses, and lavender into perfumes or antiseptics. And then Folio 3R shifts entirely to metallurgy, detailing the melting and alloying of lead, tin, copper, silver, and gold. The decryption method produces a logical, structured laboratory manual, page after page. Now, it's very important to note the current scientific status of this research. As the source material explicitly states, this method provides the most probable reading based on the available geometric structure and historical references, but final scientific validation by independent experts is still pending. While the combination of the Fontana cipher and the Capelli database creates an incredibly compelling and functional translation, it absolutely remains a newly proposed theory. The academic community is still going to need to thoroughly test and independently verify these findings before it becomes accepted historical fact. But stepping back for a second, this entire process beautifully highlights why understanding the foundational principles of historical manuscripts, like the massive abbreviation systems decoded by Capelli Online, is so vital. It's not just about reading old handwriting. It's about reverse engineering the minds of the past. Which leaves us with a fascinating thought to end on. If the ultimate cold case, the Voynich manuscript, is finally yielding its secrets to digital tools and a deeper understanding of medieval shorthand, what other historical mysteries are sitting in archives right now just waiting for the right key? Thanks for joining me for this explainer, and keep questioning the past.